Hello, in this video we're going to have a look at angles associated with triangles. So the first thing that we need to know are the types of triangles. So one type is a right angled triangle. So as in this triangle here, that triangle is a right angled triangle because we have one right angle within that triangle. We also have isosceles triangles, equilateral triangles, and scalene triangles. So the first example I want to look at is looking at right angled triangles. So a right angled triangle, of course, has one right angle. Remembering that a right angle is 90 degrees. So here is a gate and here is one right angled triangle. So the right angle is there. We also have isosceles triangles. Just grab another colour. So isosceles triangles are triangles where two sides of the triangle are of equal length, which would mean that two base angles are the same. So if I go back to my example with the gate here, this triangle here is an isosceles triangle. So this blue one here. And you can see that these two sides are the same length. So we place these little symbols. Those symbols there indicate that those two sides there are of the same length. Now the base angles for any isosceles triangle are at the base of the two lengths or the two sides that are of the same length. So this angle here and this angle here are the base angles. So those two angles there are called the base angles. And they are actually equal. So any base angles in any isosceles triangle will always be the same. Now equilateral triangles are triangles whereby all the sides are of the same length. So we would have this scenario going on. So you'd have these little sticks on each side of the triangle indicating that those three lengths are the same, which means that all the interior angles, so that's called an interior angle, all the interior angles of an equilateral triangle are the same. Now if I just scroll back to this most important rule here, which I skipped at the beginning, angles in a triangle add to 180 degrees. So regardless of the triangle, all the interior angles will add to 180 degrees. So if we go back to the equilateral triangle here, that would mean that each interior angle would be 60 degrees. So 60, 60, and this angle here would also be 60 degrees. So that's for equilateral triangles. If we go back to our fence gate here, if we look at, say, the isosceles triangle, say we knew that this angle here was 110 degrees. Knowing that the base angles are the same, are equal, that would mean that if this is 110, I have 70 degrees left over to make up to 180 degrees, which is the sum of the angles inside a triangle. So then this base angle would be 70 divided by 2. So that base angle would be 35, and this base angle here would also be 35 degrees. So base angles are the same. If we have a look at another isosceles triangle, say this triangle here, so this is also an isosceles triangle. We know that that length is the same as that length there. And because we know that this is a right angle, we've worked out that this angle here is 35 degrees. If this is 90, then this angle must add to make 90. So 35 plus 55 makes 90 degrees. So this angle here must be 55 degrees. So if we go back to looking at our isosceles triangle, this one here, that would mean that, that would mean that this angle would also be 55 degrees, which means that this angle here, 55 plus 55 is 110. Therefore, this angle would be 70 degrees. So that's angles inside an isosceles triangle, but you can also see that we've got a straight line here as well. So we could have used the rule that angles on a straight line add to 180 as well in order to ascertain that that was 70 degrees. So you can begin to see that we're using multiple angle rules to actually calculate these angles. So that's, we've got right angled triangle, isosceles triangle and equilateral triangle. And the last type of triangle are scalene triangles. Now scalene triangles, all the sides are of different lengths and all the angles are of different size as well. So we've got an example here, and we can see we've got a large isosceles triangle. So the triangle on the outside here is an isosceles triangle due to these little points here. And we've got three interior triangles. Now each of these triangles, if I were to call them triangle 1, triangle 2, triangle 3, we can see that at least triangle 2 is a right angled triangle, because we can see that this angle here is a right angle, so that's a right angled triangle. And then triangle 1 and 3 are scalene. That would mean that all the interior angles of each of those two triangles would be different. So let's go ahead and work out what these angles are. So I've got 63 degrees here. I have that side of the triangle, which means that this is a straight line. So I can work out 63 plus what will give me 180 degrees. So 63 up to 80 is 17, then I need another 100. So this should be 117 degrees. So now if I look at triangle number 1, I've got 21, 117, then I can actually work out this angle here due to the fact that angles inside a triangle add up to 180. So if I've got 21 plus 117, I get 138. So this angle here must be 42. So you can see that triangle number 1 is indeed a scalene triangle. All the three angles are different, so it is therefore scalene. So you might want to pause the video now and then just see if you can work out this angle here, this one, this angle and this angle using the angle rules that you know. Just to assist you in working out those four angles, let's label the vertices of this triangle. So A, B, C, and then let's label these other points here. So this point is D and this point is E. So remember to label your angles with the three letters using the angle symbol. So if I'm looking at this angle here, that would be labeled angle B, E, D. Okay, so see if you can continue to work out those 4 angles in red. How did you go? So let's have a look at working out angle BED. So angle BED is this one here. We know that this angle is 90 and this angle here is 63. So 90 plus 63 is 153. To make up to 180, I will need 27. So angle BED equals 27 degrees. And remember the reason is angles in a triangle. So you can just draw a little triangle for the word to represent the word triangle. Angles in a triangle add to 180. Okay, let's find this angle here. So angle AEB. You can see that angle AEB is on a straight line. So we already know that this is 27. So 27 plus 21 is 48. So this angle here must be 132 because angles on a straight line add to 180. Now what else can we find? So we've found this angle here. We can now find angle BAE. Angle BAE because we have an isosceles triangle. So remember those 2 little sticks there mean that this side is the same length as this side here, which means that these 2 angles, so angle BCE is equal to this angle here. So angle BAE is equal to angle BCE, which is equal to 42 degrees. And the reason for that is base angles in an isosceles triangle are equal. So you can abbreviate it or you can just write 4 words. So BAE is 42. We know this one here was 132. So 132 plus 42 is 174 degrees. So this must be 6 degrees. So if I just squeeze that in down the bottom, angle ABE. So just take care you're writing you're naming the angles correctly. So angle ABE, okay, which is this angle here, is equal to 6 degrees, and that's because angles in a triangle add to 180. Okay, so I've got one more example here. It's a fence gate, and I'd like you to have a go at it. You need to calculate angles small a, small c, small b, and small d. So try and, when you calculate these angles, use this kind of working here and give the reasons as well. So if you pause the video now, have a go at it, and then when you play the video again, I will have all the working for you. How did you go with those angles? So I've just relabeled angle A, B, C and D correctly using the 3 letters there, and of course you don't have to calculate them in order A, B, C and D. The main thing here to recognize is that we have quite a few isosceles triangles due to these little sticks here indicating that those 4 sides are of equal length, And then we also have right angles. So this is our fence gate. So we've got 4 right angles there. And because these are wooden panels, diagonal wooden panels, we also have the fact that these 2 angles here are vertically opposite, they are equal. And we also, with these wooden panels going across here, they are straight lines. So we've also got angles on a straight line. So when you start getting examples like this, you want to incorporate all those basic angle rules: angles on a straight line, angles at a point, vertically opposite angles, angles inside a triangle, base angles of isosceles triangles being equal. You end up incorporating all those rules in order to solve a geometric problem. Now for higher levels, you will need to use reasons. So start getting into the habit of writing reasons after you have calculated an angle.